All right, a big welcome to all you engineers and product designers out there. If you're an OEM, you know that your choice of battery isn't just another line on your bill of materials. It's pretty much the heart of your entire product. So today, we're going to do a real engineering level briefing on what is probably the most critical power decision you'll make. Lithium-ion versus lithium polymer. Let's get right into it.
You know, this quote really nails it. Think about it. The power source you pick, it's going to dictate the shape of your device, how much it weighs, its performance, even how long it's going to last. It's really the one choice that sends ripples through every single other part of your design.
And really, that leads us right to the core dilemma for any OEM, right? Is cost your number one priority? Like, are you trying to shave off every last fraction of a cent? Or are you building something sleek and custom where the form factor is everything? This one question is going to guide our whole conversation today.
Okay, so here's how we're going to tackle this. First, we'll define our terms. Then, we'll compare the physical and performance differences. We'll analyze safety and cost. And then finally, we'll put it all together into a decision-making blueprint for your next project.
Okay, first things first, let's make sure we're all on the same page here. Because honestly, the terms Li-ion and LiPo can get a little confusing. Technically, one is just a type of the other. But in the industry, when we're talking to suppliers and engineers, they mean very specific things.
So, for the rest of this conversation, when we talk about Li-ion, what we really mean are those hard, steel-cased cylinders, like the classic 18650. And when we say LiPo, we're talking about those soft, flexible pouches you'd find inside your smartphone. Getting this distinction right is absolutely crucial for everything that follows.
All right, let's get into the most obvious difference right away, the physical shape. And this is where we introduce our two main players, the rugged, reliable workhorse and the super adaptable chameleon. So in one corner, you've got the Li-ion cell. It's a standardized steel cylinder, right? It's built for toughness and mass production. And in the other corner, you have the LiPo pouch, a soft foil-wrapped cell that you can basically shape to fit into almost any nook or cranny. Their shells really define what they're good at.
So that steel can on the cylindrical Li-ion, it's kind of its greatest strength and also its biggest weakness. It's unbelievably tough, but it's also bulky and heavy. I mean, you just can't cram an 18mm thick battery into a tablet that's only 6mm thick. It's not going to happen. And when you pack them together, you always get those little empty spaces between the circles.
Now, the LiPo, on the other hand, is a master of using space efficiently. It's roughly 20% lighter, and you can get it custom-shaped to fill every single bit of empty space in your design. But, and this is a big but, that soft pouch gives you zero protection. Your device's housing has to be the battery's armor. There's no way around it. Okay, we've got the shapes down. But what about performance? How do they actually behave? And we're not just talking about capacity here. We're talking about how they deliver that energy. Are you looking for a quick, powerful punch, or are you in it for the long, steady marathon?
This is really the core trade-off when it comes to performance. Think of LiPo batteries like high-performance sprinters. They can just dump a massive amount of energy in an instant. The cylindrical Li-ion cells? They're the marathon runners. They can't sprint nearly as fast, but man, they can go the distance, lasting for way more charge cycles.
Let's take a look at this C-rate comparison. It's pretty stark. A standard Li-ion cell might discharge at, 1 to 3 times its capacity? We call that 1 to 3 C. But a high-rate LiPo, we're talking 50 C, sometimes even higher. That's how a tiny battery in a racing drone can pull enough amps to give you that insane acceleration. Okay, but here's the other side of that coin. Longevity. That tough, perfectly sealed steel can, it helps a good quality Li-ion cell last for, say, 500 to 1,000 cycles. That's a lot. The LiPo pouch, though, it's more delicate, it's often pushed to its limits, and you're typically looking at 300 to 500 cycles. That's a huge deal for a product you want to last for years. And that physical construction ties directly into our next big topic, which is safety. This is a critical one. Look, both are safe when they're designed and handled properly, but their physical forms mean they fail in very different ways. So, that Li-ion steel can, it's basically a pressure vessel. It's got built-in safety features designed to handle internal pressure. The LiPo pouch, though, it can't contain that pressure at all. So instead, it does something else. It swells up. It puffs. And that's actually a safety feature, believe it or not. It's a big visual warning telling you, hey, something's wrong here. So when you're thinking about LiPo safety, the number one thing is puncture risk. That soft foil casing is it's easy to pierce. And if you puncture a LiPo, you're almost guaranteed to have a fire, right then and there. This part is absolutely non-negotiable. If you're using a LiPo, the case of your product has to be tough. It must protect that battery from any kind of impact or puncture.
All right, let's talk about the one thing that often makes the final call for an OEM: the cost, the bottom line. How are these two options going to affect your bill of materials?
Okay, here it is, plain and simple. You're going to pay somewhere between a 10 and 30% premium for a LiPo battery over a cylindrical Li-ion with the same amount of energy. And that, right there, is the price of admission for that design flexibility and lighter weight.
So why the big price gap? Well, it all comes down to manufacturing. Think about it. Cylindrical cells like the 18650 are churned out by the billions on these incredibly efficient automated production lines. LiPo manufacturing? It's often more custom, it's less automated, and you need special tools for every different size. All of that just adds to the cost.
So, we've walked through the physical shape, performance, safety, and cost. Now, let's pull all of that together and build a practical blueprint to help you make the right call for your next project.
Okay, think of this table as your go-to engineering cheat sheet. If you're designing something like wearables, drones, or a super slim tablet, that lightweight custom shape of a LiPo is almost always going to be your best bet. But if you're working on power tools, power banks, anything where rock-solid durability and low cost are the main goals, then the cylindrical Li-ion is your workhorse. It's the clear choice.
So let's boil it down. You should choose a LiPo when your design basically forces your hand. If you absolutely must have the lightest weight possible, if you have a really weird or tight space to fit it in, or if you need those massive bursts of power, then yeah, the LiPo and its price premium are where you need to be. On the flip side, the cylindrical lithium-ion is the smart, practical choice, especially when cost is your main driver. If you have the space to design your product around a standard-sized cylinder, you are going to get a power source that's cheaper, tougher, and lasts longer. There's a reason they're used in so many products.
You know, at the end of the day, there's no such thing as a perfect battery. There are only trade-offs. The best choice is always going to be the one that fits the specific constraints and priorities of your product. So now you have the framework. The question is, which path will you choose for your design?